哇，你好吃啊 Hello? Hey, William. Hey, can you help me buy 吃茶 or damn hot the weather?
Okay, Ken. What drink you want?
Just give me like green tea with pearl lah. Yeah, what ice level they have
Give me a moment. I check the staff.
Okay, can.
Okay, they have less ice and full ice.
Just give me full ice ba.
Okay.
Yeah, faster come the weather damn hot Thank you.
Okay, can.
Okay,
Bye.
bye.
Okay, order.
Green tea.
Ice level.
Full ice.
Green tea full ice.那。
Okay, thank you.
下次不要来了哦。
One eternity later.
Hey, Vinny, 你的 green tea 来了。
Thank you.
Here you go. Your ice cold green tea with pearl.
Huh? Ice green tea?
Yeah, it's exactly what you wanted. Green tea, full ice with pearl.
NANI?!
Have you ever had your drinking experience ruined as your chilled beverage was not cold enough? If you have, then fret not, because today we'll be utilizing statistics to find out how long it takes for drinks to exceed 16 degrees Celsius, which has been recommended by experts to be the maximum ideal temperature for the consumption of chilled beverages. Using the power of regression, we're going to find out what factors affect the amount of time taken for a cold drink to reach 16 degrees. We have considered the temperatures based on different weather conditions, amount of ice, and amount of time elapsed before consumption, as we believe that these are the most important factors. Obviously, this list isn't exhaustive, and there are many other factors we have to take into account, although we deem them to be negligible. The first of our independent variables is the temperature based on weather, with data collected from AccuWeather via their website. Secondly, for the amount of ice, we utilized a full ice level where the amount varies between 280 and 350 grams of ice. As for the time elapsed before consumption, we sourced from our sample size from people from multiple locations in Singapore and ensured that they are unrelated to one another. This ensures that our sample is both independent and identically distributed.
Using R, we can input the data collected for the amount of time taken for a cold drink to reach 16 degrees Celsius. As you can see, the regression formula uses the time taken as a dependent variable that has the independent variables of temperature based on weather, the amount of ice, and the amount of time elapsed before consumption after purchase. We have to use 3 separate data sets of temperatures for different weathers. In our case, we will be using sunny, cloudy, and rainy weather. After establishing our linear model, we start by using a summary command for sunny day temperatures. We are able to see that the coefficient of temperature based on a sunny day is around negative 2.01. This shows that a 1 degree increase in temperature will lead to a 2.01 minutes decrease in the amount of time taken for the cold drink to reach 16 degrees Celsius, keeping all else constant. Based on the regression model, the temperature variable is also the most significant factor in affecting the amount of time taken for the drink to reach 16 degrees Celsius. We do the same for cloudy and rainy temperature datasets. For the cloudy weather, a 1 degree increase in temperature will lead to a 1.55 minutes decrease in the amount of time taken. For the rainy weather, a 1 degree increase in temperature will lead to a 1.85 minutes decrease in the amount of time taken.
We have decided to present 2 sets of hypotheses, H0 where beta equals to 0 for the null hypothesis. In this scenario, the independent variable weather is not a significant predictor of the dependent variable. Alternatively, H1 is the hypothesis where beta does not equals to 0. This will show that the independent variable weather is indeed a significant predictor of the dependent variable, which is the time taken for the cold drink to reach 16 degrees Celsius. In our case, we will be using the p-values for each dataset. We will use the 5% significant value. If the p-value is less than 5%, we will reject the null hypothesis, stating that weather is a significant predictor of the time taken for the cold drink to reach 16 degrees Celsius. The p-values obtained for sunny, cloudy, and rainy temperature datasets are as follows. As we can see from these results, the p-values for all the datasets are less than 5%. Hence, we can conclude that the temperature based on each of the weather is indeed a significant predictor of the time taken for a cold drink to reach 16 degrees Celsius.
Given that the ideal temperature to drink chilled beverages is 16 degrees, we want to solve the issue of determining how long it takes for drinks to exceed 16 degrees Celsius. For each weather, we have to utilize the data for the average time taken for the drinks to exceed 16 degrees Celsius for each weather. We can calculate this by using confidence interval and using the upper limit. Using the confidence level of 95%, we are able to find the upper and lower limit that contains the true average time taken for the drink to exceed 16 degrees Celsius for sunny weather for 95% of the time. Firstly, we will find the mean and standard deviation of our sample. Then, we will use the function qt and multiply by the standard deviation divided by the square root of the sample size to find the length of the interval that will be subtracted and added to our sample mean to find our lower and upper limit respectively. Repeating the same process for cloudy and rainy databases, we arrive at an upper and lower limit that contains the true average time taken for the drinks to exceed 16 degrees Celsius for each weather 95% of the time. As a result, we take the upper limit of 20.05 for sunny, 35.15 for cloudy, and 50.98 for rainy weather as our time taken for our drinks to exceed 16 degrees Celsius, to be given as our suggestion for our solution.
Since we cannot change the temperature of the weather, the next alternative is to propose suggestions on the maximum time a cold drink can remain at optimal drinking temperature, providing consumer with an ideal drinking experience for the next sweltering day. This leads us to our proposed solution, the improved labelling system. Now that we have taken in so much information, let's enjoy our favorite beverage at the ideal temperature and have the ideal drinking experience.
Introducing our augmented product, a new labeling systems for your purchased chilled beverage. Using statistical analysis, we were able to craft out a solution that provides an optimal time for the consumer to consume the chilled beverage based on the weather. Gone are the days of having a ruined drinking experience. With our new labeling system, we now know the optimal time to consume chilled beverage based on the weather regardless of rain or shine. You can now ensure the ideal drinking experience for your chilled beverage down to the very last drop.
Hey Vinny, 你的 green tea 来了。
Huh?
Here you go, your ice cold green tea.